How's it going, everybody? In this video, we are going to dive into RIP version 2 and all of the, or I should say, the majority of the features and technicalities to what make RIP version 2 RIP version 2. RIP version 2 isn't a very complicated protocol, but it's still got enough complexity that it still, to me, warrants at least a little bit of configuration. So what I'm going to do is I'm going to bring over some RIP version 2 details, and we'll talk about how we're going to do this. Now, if you're not familiar with the way we're setting this up, we're going to be running a RIP just between router 8 and 9 on this connection right here on fast 1/1 between 8 and 9, and just to basic configuration. We're going to run through just a couple of the config options that are there, explain what split horizon means, and explain what route poisoning would look like and things like that. But beyond that, that's about the extent of how far we're going to take with RIP. There's not a ton to worry about, but it's still important to know the details to it. Okay, so basically, actually I had to do a little bit of digging to find this text document, but we're going to run through some of the configuration, or the details to RIP, just so you guys are familiar with it. So RIP itself is, as you know, is a distance vector routing protocol. So a couple of these commands up here at the top are just some of the things that are only available in 15.3 code or later. But let me go through here and talk about how RIP actually works. So RIP itself is a where is it? Well, let me talk about classless routing, and this will actually answer a lot of these questions. So, classless routing behavior. RIP is actually a classless routing protocol. RIP version 1 is a class full routing protocol, meaning it can only advertise the major subnets. RIP version 2 qualifies as a classless routing protocol because it advertises the subnet mask. RIP version 1 does not. So, basically the idea is, if I know classless routing rules are pretty straightforward. So it's not based on an IP address class. So longest match will automatically win because the subnet mask is advertised. If a match is not found, a default route is used for the packet. If a match is not found and there is no default route, the packet is dropped. So basically, the default route, or the gateway of last resort, or an all zeros route, means that it doesn't matter what the IP address is. If there's that default route available, it's going to forward the traffic out to wherever the default route is pointing towards. Now, distance vector routing protocols basically mean distance meaning how far and vector meaning which way. So RIP metric is based on a basic hop count, so 1 through 16, 16 meaning it's inaccessible. It utilizes split horizon and poison reverse. Basically what this means is, if you have a split horizon, it says never advertise out a route in the interface it was learned on. So pretty straightforward type of setup. This can break your network, and EIGRP and RIP both work off of this concept. So if you're running DMVPN or frame relay or something like that, you would have to make sure that you would be disabling split horizon, so that if a route was learned in on a particular interface and it needed to go back out to the same interface to update a remote peer, that would be available to be done. Now, poison reverse, basically what this means is you're going to advertise a route back out the interface it was learned on, but with a infinite metric. Or in RIP's case, infinite metric is going to be a hop count of 16, which means it's inaccessible, and whatever EIGRP's maximum metric is, that would be advertised back out. So that's the basic idea behind what the differences between them are. Utilizes UDP port 520 at layer 4 for communication, and it has a default AD of 120. So the idea behind this is, if you're using UDP, that's for transport. And if it's going to communicate with somebody else, it's going to use multicast to form adjacencies. Once adjacencies have formed, it doesn't do like an active adjacency with a hello protocol like OSPF and EIGRP do. It uses multicast, and then every 30 seconds it advertises its entire routing table out. So basically, it sends, and it says this right here, it sends gratuitous updates every update time, which is the default is 30 seconds, and all of the timers can be manipulated. Version 1 sent to the broadcast address of all 255s, and supports the advertisement of /32 routes as long as it is a subnet in the same major network being advertised. So basically what this is saying is you can't advertise 10.1.1.1/32 if the major network is 172.16/16. So because they don't belong to the same major network. And what they mean by the same major network is this is the major network and this is the major network. So 172.16 and 10 are two different major networks. If they're not belonging to the same, you cannot advertise a host route. Version 2 utilizes multicast at 224.0.0.9. So you can, whenever you have a RIP peering on this two RIP routers running on the same broadcast segment or point-to-point segment, they will both form adjacencies using this. It can be configured for unicast updates using the neighbor command, and it can be configured for broadcast updates using IPRIP version 2 broadcast. The main configuration with the network command is network of 10, meaning it doesn't matter what this, if it's 10.1.1.0/24, it's still going to get advertised as 10.0.0.0. Same thing with the network command for 172.16 and then 192.168.1.0. So because of the fact that it still is a distance vector protocol, it's still going to use the network command and is going to default back to its major, its classful range. Is what it's going to do. So what makes RIP version 2 classless? It advertises the subnet mask in the routing updates. That's what makes it classless. So it enables the use of authentication. You can tag routes during redistribution, and it sends multicast updates. So also the next hop can point to a better next hop if info is available. Basically, what this means is you can actually redirect your traffic to a different area if you need to, and they typically refer to that as an IP redirect. And this is not available if you do not have split horizon turned off. And basically, the idea behind this is you can actually type in IPRIP next hop and type in the IP address. So if you're using, you can actually tell the router the next hop if you want to do so. So if you need to go from router 1 to 2 to 3, and 1 to 3 could talk to each other, but you need to set it up for router 1 to 2 and then 2 to 3 for whatever reason. Usually it's in extremely secure environments. That's what you would do that, but there is a capability of doing that. So enabling RIP, you can go to the global process, type in router RIP, enable the interface process. So you type in network command, the network.x.x.x.x. So it matches the major network only. As you can see, these are the ranges it's going to apply for. So basically, what this basically does is that the network command advertises RIP out interfaces that match the major network statement in the network statement. So any specific manipulation takes advanced configuration. Now, let me be very specific here. When you're dealing with any of the IGPs, RIP, OSPF, or EIGRP, when you type in router RIP and you advertise the network command, or actually I should say when you enter the network command, you are not advertising that route. What you are doing is you are actually turning on that particular protocol's process on that interface. And therefore what ends up happening now is the protocol is now actually able to forward, send and receive traffic on that interface on behalf of the process. So it turns on the IGP process at the interface level. So if the network command is very specific and types in and you say 192.168.1.1, that means that network command is only going to work on an interface that's got the IP address 192.168.1.1 configured. If there is no address configured, the network command will not take effect. If you have a broader statement where it's 192.168.1.0 and there happens to be one or more IP addresses configured in that range or on an interface on that router, then that particular process will take effect. And now I could go in a little bit deeper here and talk about how the more specific you are in your network command will be the more specific the interface will be, and there actually is a way to be very granular. So the majority of the idea is pretty straightforward. And actually, let me draw this out. I think it'll be easier for you guys to understand this. All right. So from the breakdown, we're going to draw a router. We have a router here. We have interface 1, interface 2, interface 3, and interface 4. Okay, this guy right here, we turn on the process. So we have an IGP process running here in the background, and it's got all these interfaces are configured with an IP address. So we'll give this guy 10.1.1.1 10.1.1. This guy is 10.1.2.1. This guy is 10.1.3.1. And this guy is 10. That's a horrible 10.1.4.1. So basically what ends up happening now is if you go in here and you configure the IGP process, if you're with RIP, you type in network net and you type 10.0.0.0. That means that any interface beginning with 10, so this guy, this guy, this guy, and this guy will all run RIP. Okay? Now, if you get more specific, let's say, for instance, now you turn on, so this will be RIP. Let's say we turn on EIGRP. And then we type in network of 10, or let's do 10.1.0.0. What's going to end up happening is any interface running 10.1 will run the EIGRP process. Okay. Now, actually, what's going to end up happening now is the RIP process will still be operational, but because of the fact that EIGRP has a better administrative distance, this means that it's going to take effect to where RIP will pretty much be disabled, where RIP won't run. Actually, that's not entirely true. The process will still run, but it'll run on all 4 interfaces, so you'll be receiving updates for all of them. Now, if we take this a step farther, we go OSPF. We type in network of 10.1.2.0. We can go in here now, and we're going to have RIP running on all 4, right? So we're going to have RIP, 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 and RIP. We're also going to be running EIGRP, EIGRP, EI, E, and then an E. And then if you type in OSPF, only OSPF will run on this interface because I'm getting more and more specific with my network command. Now if I type in, let's say for instance I type in OSPF for network of 10.1.3.1, that means OSPF is only going to run on this particular interface. Now let's say if I add another interface here. Okay, this one's 10.2.2. Actually, that's a bad example. Let's do 10.1.6.0. This is going to be another EIGRP and a RIP. Okay. Now, if I was to start adding routes in here, then, or sorry, I should say, if I was to start adding interfaces in here, depending on the network command that I use to apply to will determine who's going to run on there. Now, you might say, okay, you've got RIP running on the same interface, and so is EIGRP. Who's going to win? Which routes will I install into the routing table? Well, that's where administrative distance comes back into play. Remember, administrative distance means how believable the route is. So if you have RIP with an AD of 120, you have EIGRP with an internal of 90 and an external of 170. You have OSPF here with 110. If you have EIGRP running on this interface, EIGRP will win. If you have EIGRP running on this interface, EIGRP will win. If you have OSPF running on this interface, but because I have a network command that's more specific than 10.1, OSPF is going to win. Actually, let's take this back. EIGRP will win. So EIGRP will win this one. EIGRP will win this one. OSPF will win on this interface. And if I have 10.1.1.3, OSPF will win on this one as well, because the network command is more specific. And the more specific you are, will determine which protocol will run on which interface. So you'll have an EIGRP route. You'll have a EIGRP here, OSPF here, and there's I know you might be asking, well, what happens with RIP? Well, if you have just a general network statement where, let's say that EIGRP doesn't match, let's say we change this over to be a 10.1. Okay, now this is 10.1. This means that that EIGRP will win on this one. Actually, I meant to do this one. EIGRP will win here. EIGRP will win here. Let's see here. RIP will win on this one because it's 10.1.2. Or I'm sorry, no. Yeah, RIP will win on this one because it's 10.0, 10 all. So RIP will win on this guy. OSPF will win on this one. OSPF will win on this one because we have a specific network command stated. And then we have RIP is going to be running on this guy. So we have a specific network command here, but the drawback to it is it's going to default back to this guy. So RIP will win on this one as well. And then we have this network command of 10.1.3, which is running here. So as you can see, just by adding in or changing the network command will change which interfaces will effectively run which protocol. Now, with all that being said, how does that really affect us? Well, typically you're not going to get that granular. You're not going to have that much stuff to worry about. The one thing that I want to make sure that everybody understands is when you're dealing with RIP, there's some specific information that you have to understand. So with RIP, you have auto summarization, which means that by default auto summary is going to be enabled, which means that no matter what network statement you advertise, it's automatically going to summarize back to the major network range. So RIP version 2 is classless, but it does automatic classical summarization by default. To issue no auto summary, then this way here you'll be able to add longer. You'll actually be able to add more specific subnets. And now it says advertisements between major network boundaries are summarized to the classical boundary. This can result in traffic black holes, meaning if you have a 10.1.1.0, actually let's get a little bit more specific. If you have let's say you have 171.0.0.0 and 172.0.0.0. 171 and 172 are two specifically different classical boundaries. Now they're still in the same classical boundary, but because of the fact that they are two different major networks, they're going to be summarized back to class B, but they're going to be individual routes because they're both different major networks. So anything that's summarized is 171 1.1, 172.2.2. All those routes are going to be advertised back to the 171 and 172 subnets. If you type in no auto summary, that will the flexibility of that will go away, which means the routes will go from 171.0.0.0 to 171.1.1. whatever. Same thing with 172. The 2.2 will now be advertised, but they will summarize themselves back to the 171 / whatever you configured originally, because that's going to be the major network. The major network cannot be crossed. That's the main thing I'm trying to get across to you. Then we have RIP timers. RIP timers are pretty straightforward. You have the update timer, which is 30 seconds, and how often do I send out routes. And the eval timer is if we don't hear about a route after this long, it must be down. Then we have the hold time. This is Cisco proprietary, and basically when invalid and hold time are both triggered, these are actually the same timer interval. And then we have a flush. From 240 seconds after the last update is heard, if you don't hear anything within 4 minutes, you're going to flush the route completely. So manipulating timers is pretty straightforward. The sleep timer can be added optionally to delay updates. And then we have our timers. Our update is 30 seconds. Invalid is 180. Hold down is routes enter hold down after 180, which is once they are determined to be invalid. And let's see here. So we have some caveats, and then so now what we're going to do is we're going to take a look at authentication. Is pretty straightforward. You just configure a keychain, and then you map that underneath the interface, and away you go. I'll show you guys how to do that real quick. And then summarization, you have both auto summarization and manual summarization. You would type in IP summary address, RIP, and then whatever the range you want to advertise. Pretty straightforward. And then RIP does a default advertisement, and you can just do a default information originate at the router command, and it's going to advertise a default route. And there's some other options for doing conditional default routing, which means you can track something and some other stuff. So it's pretty straightforward for the most part. But beyond that, I don't want to get too much more deep into it because of the fact that we're going to get into some of the additional pieces to it. And I don't know how deep they're going to take RIP. So what we're going to do is we're going to take a look at going here on GNS3, and we're going to configure RIP between 8 and 9. So we're going to go to router 8. We're going to go to global config between the link of 89. We're going to go to global config. We're going to type in router RIP. We're type in. We have quite a few commands here. We have address family auto summary. We're going to type in no auto summary, which disables the automatic network number summarization. So no auto. Then we're going to type in version 2. If we don't specify that, it will say version 1. And then from there, we are going to simply type in a network command of 192.168.89.0 question mark. And if you notice, there is no wildcard like you might see in OSPF or EIGRP, which we will be covering. That's it. We go to router 9. We type in router RIP, no auto, version 2, network of 192.168.89.0. Then we're going into interface loopback 0. Actually, we're going to go back to router RIP here. And we're do show IP interface brief. Don't I have interface loopback 0 IP address of 10.255.9.9? Thought I had a loopback configured, but I guess not. And then on the same thing on 8. So do show IP interface brief. Okay, so we're typing network of 10. And the same thing on 9. Router RIP, network of 10. That's it. Pretty straightforward for the most part. And then we're going to go to do show IP route. And we have a RIP route. We have the 10 network in here, right? We learned 10.255.8.8. So do ping 10.255.8.8, and we can ping it. If we do we jump out here and do a show IP RIP question mark, we only have a couple options. We have the neighbors, which is going to be nobody, which we database is going to be not much is going on here. And that's pretty much the extent of what we have going on here. And we can do the easiest way to determine things are running is actually do a debug IP RIP. That is it. So what we're going to do is we're going to sit here for just a second. We're going to, if you wait about 30 seconds, you'll see an update come in, and which we did right there. So we received a version 2 update from router 8, and via us in 1hops. You'll see that we're sending a version 2 update to 224.0.0.9 via loopback. This is our router ID. We building the update entry. We sent. We're telling router 8 about a route that it sent us, because what ends up happening here is RIP will automatically send all of its routes no matter what you tell it to do. That's pretty straightforward. So now what I'm going to do is I'm going to take this and from I'm actually going to go to global config and type in router RIP, and I want to type in neighbor command. So go do the no network command here. No. And so basically we're going to type in neighbor. The neighbor is going to be 192.168.168.89.8 question mark, and then hit enter. So we're going unicast now, and we're sending a let's see here. I don't believe it's going to actually work because the other side's got to be receiving unicast as well. So we're going to go to router 8 and hit the up arrow here a couple times. And type in neighbor 192.168.89.9. Hit enter. And if we go over to router 9, you'll see that we should be learning unicast from our neighbors. So, and do show run pipe section RIP. Are still advertising the network command. Not sure why it is still sending to that guy. Let's think here for a minute. But that's how you would do. Should be sending directly to it. So let's see here. Interesting. Maybe because of the fact that, well, no, neighbor. It's doing multicast. Oh, which is actually supposed to flow over to unicast. So let's go to interface. We're gonna say interface fast 1/1. We're typing IP RIP. We have some options here. We can send. We can send and receive the versions we want to do. So we can do a receive question and a version, and then we can say 1 or 2. So we can say 1 and 2, and if we do 2, that means you're going to receive both. So I type in do show IP protocols. You're going to see here that let's see here. That's interesting. Maybe I need to issue the network command. So let's go to router RIP network of 192.168.89.0. As I know in EIGRP you have to issue the. There it goes. Okay, that was the problem. So I don't use RIP very often, so that was the problem. I was still trying to send an update to 224.0.0.9, and now it's sending it up via unicast. And we're going to go over to, yeah, see now it's sending it via, now it's sending version 2 updates this way. So what I'm going to do is I'm going to go on 8 and type in network of 192.168.89.0, and I'm going to go back to 9. So we should receive in stuff. We're sending, we should be receiving an update now. And it's every 30 seconds it's going to happen. It's going to happen. So, let's see. I'm seeing sending, but I'm not seeing any receiving. Let's see here. From 8. Receive. Okay, there it is. So receive version 2 update from this guy for this particular route. It's flash update is still okay. So there's still updates sent to 224.0.0.9, but they're sending the updates are unicast, where before they were let's see, does it state it? I believe they were to unicast. Yes. Oh, 1 second here. Let me climb back up to the top. Go back all the way to the very, very top. Right here. So, received. Let's see. We should be receiving a. Yeah, I don't see it. But basically, the idea is if you use the neighbor statement, that's going to do. That's going to send updates as unicast, and as you can see down here at the bottom. We are receiving updates from the other side, so sending version 2 update to the IP address, and it is receiving updates inbound. Receive version 2 from router 8, which means it's working. If it was unicast or multicast, Let's see here. Received. I'm looking for a received inbound, but then again, I don't want to spend a ton of time on RIP. I don't really see. I don't know if they're going to test you that hard on it, but I can't see them really focusing too much on this. And okay, so as far as I'm concerned, everything's working as it needs to, and that's how you would do unicast versus multicast communication. That's as far as I'm going to take RIP. Just to turn it on, show you guys how it would actually work, and go from there. So I'm going to do a no router RIP and turn it off. There's anything on this side, no router RIP, and then that's all there is to it. So RIP is done. Authentication wise, you're just creating a keychain and assigning it to the so you're on interface fast 1/1 IP authentication would be mode, and you type in, or actually I should say IP RIP authentication would be mode, and you'd have clear text and MD5, and then you just create a keychain, so MD5, and then you would do that, and then you type in IP RIP authentication, and you'd say keychain is going to be whatever the name is, RIP, and then you would type in keychain is going to be RIP, and then you key 1, and then you type in key string would be Cisco, and that's all you would do. So that's all there would be there to it. So create a keychain. That's like 3 commands. So not very difficult at all. So exit out of here, no keychain, RIP. So pretty straightforward for the most part. But beyond that, once I deploy these videos, if you guys want to see more RIP, I've actually got a bunch of RIP videos already done, and I will show you where to find those. Okay, so I went to my YouTube channel, and if you were to go to the CCIE Routing and Switching version 5 technology videos, and scroll down to the bottom here, or down a little ways, past IP routing, you'll see that I have already done a significant amount of RIP. I've already covered RIP in detail on a lot of this stuff already. So a lot of this stuff has already been covered. I'm not going to go back through a bunch of it and already recover what I've already done. This will take you to a very, very deep level with RIP and go from there. But beyond that, that's pretty much where it sits with RIP. But like I said, if you want to go any farther with RIP, you are more than welcome to do so. But at this point in time, I really don't see a benefit to going any farther with it. So this is where you can find them. I hope this has been informative for you, and I'd like to thank you for viewing.